Cuttlefish is a universal 3D printer driver that pushes the limits of multi-material full-color 3D printing, providing unparalleled quality. It is printer agnostic. This means it supports different manufacturers such as Stratasys and Bimaki, and this with the same workflow. It is used in industry for individualized mass production since 2016, for example in Hollywood, in the gaming industry, and in healthcare.
We are approached by companies that have the highest demand on geometric and visual quality for their prints. Cuttlefish ensures a very high color accuracy and texture level of detail. It is the only tool on the market available with joint color and translucency reproduction using simple RGBA textures. So you can paint in your texture to create translucencies in your part, simplifying the design process. Using displacement maps, Cuttlefish can reproduce detailed surface structures, so you can paint in a displacement texture to add fine geometric details into your print. Furthermore, Cuttlefish is able to remove starcase artifacts, which is especially important in case of small prints.
For decision support, we provide a plugin called Cuttlefish Proof for simulating the appearance of the print on a display, avoiding misprints. Cuttlefish includes an automatic hollowing feature that can substantially save material costs. If the printer's firmware allows it, Cuttlefish can also reduce the thickness of the support material layer, allowing further material savings. Our volumetric voxelizer is robust to meshes with holes and even open surfaces, allowing a fully automatic slicing process. No extra tools or manual processing is needed, which saves time and costs. Hot folder functionality and automatic nesting reduce average printing time and allow individualized mass production.
Our expertise in data-driven design can help our customers to adapt or design new applications with a digital workflow that is particularly optimized for additive manufacturing. In one of these projects, we collaborated with our partners to develop a software that automatically generates models of artificial eye prostheses optimized for full-color multi-material 3D printing. This approach revolutionizes an old artisan craft, introducing modern additive manufacturing processes without requiring the ocularists to become skilled in 3D modeling.